Hi everyone, I hope you are doing well. So today I'll try to show you how you uh, use this OpenSSL. So we'll start from symmetric encryption with OpenSSL. So we do have two different types of encryption techniques, symmetric and asymmetric. The symmetric encryption is different from the other techniques. It uses the same key to encrypt and decrypt uh, the data that we have. So here we have examples of symmetric encryption, Blowfish, advanced encryption standard, the data encryption standard, and reversed cipher 4, reversed cipher 5, reversed cipher 6, and so on and so forth. We do have so many different algorithms. I'll show you in the practical session. So here we do have two different types of symmetric encryption techniques, the block and the stream one. So the block symmetric encryption is used to encrypt block of electronic data, whereas in a stream symmetric encryption, it is used in a data stream most of the time. Whenever we want to stream data, we use the stream symmetric encryption. So in here, we don't need to retain the data in a memory, but simply it streams over the wire. So today we'll try to see how does the data encryption standard works. So this algorithm uses 64-bit plain text, and it has 16 rounds of permutation. The key size is 64-bit. You have to remember, because whenever we try to implement in OpenSSL in your terminal, we need to remember these things. The key size, at least you have to remember, as it is 64-bit. Number of subkeys, 60 subkeys, and the subkey size is 48-bit. And finally, we'll produce a ciphertext of 64 bits. So OpenSSL, it is a cryptographic toolkit which operates on the top of the transport layer, and it can encrypt and decrypt data. It can compute a message digest. It can create a digital certificate and can create a timestamp. So these are the different things that we can perform using OpenSSL. And our today's practical session, as I already told you, it is using the DES, this symmetric encryption mechanism or algorithm. So in here, we first create a plain text, and then we generate a random key. Using the generated random key, we encrypt and produce a ciphertext, and then finally we'll try to see how we decrypt the ciphertext and produce a decrypted text, which is stored on the decrypted.txt. So today we'll try to see this in practical. So let's go to our terminal. So I will try to show you in my Kali Linux machine. First, let's check whether it is installed or not. So to check, open SSL version. So the version for my OpenSSL is 3.0.11, and then to go through the manual of OpenSSL, man OpenSSL. So here is a manual. So as I already told you, OpenSSL is a cryptographic toolkit which is implemented on the top of the transport layer, which is used to secure the data communications that we have into different communicating parties. OpenSSL is a command line program for using various cryptographic functions. So here are the different functions, as I already raised in my earlier slide. You can create and manage private keys and public keys in different parameters. Public key cryptographic operations, the creation of X.509 certificates. You can produce the different certificates, and calculation of message digest and message authentication codes, encryption, decryption with cipher. All these things are performed using this OpenSSL on the top of the transport layer. Here we do have so many different standard commands. So go through all these things and try to understand how this OpenSSL works, and try to understand the different functions and commands that it has. So next to, by the way, I urge you to go through this manual and understand it very carefully. And then I will try to show you OpenSSL ink ciphers. So here are the different algorithms in OpenSSL. In OpenSSL, we do have AES, Advanced Encryption Standard, with 128 keys, 128, 192, and 256. And also we do have ARIA, and also we do have Blowfish here, Blowfish. And today we'll try to see DAS, the data encryption standard with cipher block chain. So this one. So first, as I already told you, we need to create the plain text. So to create the plain text, we can use gedit plain text.txt. So here we need to write some text which is going to be encrypted. So hi, data home. This is the secret message that we are going to encrypt using DAS. So I already saved it. And if you want to display it, you can use cat command, cat plain text.txt. So here is it. And then next to this, you can use urandom to generate a random key. So urandom is a command which is used to generate randomly generated hexadecimal numbers. So to generate, we use cat command, cat dev urandom random, then head -1. That means the first line, and we can save the random bytes in bytes.bin. So I already created the random numbers to random bytes.bin file. So to display this, we can use xxd random bytes in the first line. By the way, if we do not use this head -1, it will be almost 3 different lines. So to display only the first line, we can use head -1. So here we go. It will display only the first line. So next to this, and now we do have the plain text here, which is created using gedit, and the text that we have in the plain text is "Hi, I'm Gaetan." This is a secret message, it says. So we are to encrypt this with this key. So to encrypt, we use OpenSSL Inc. and then the algorithm that we use is this one, encrypt. Then our input file is plain text.txt, the file that we already created earlier. And then our output file is cipher text.inc, and then we use no salt command. This is if we leave it simply, by default it salts our algorithm. That means it uses a random text to encrypt our data, but we don't need to use that random text. So our initial vector is 16 byte, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 zeros. And then our key, our encryption keys here, we use 16 byte, 16 bits. No, 64 bits. That means this is hexadecimal. So each digit represents 4 different bits. So whenever we multiply 4 by 4, we'll have 64, 60, no, the first one, 1, 2, 3, 4. So 4 by 4, 16, 16 plus 16 plus 16 plus 16. That means we will have a 64 bit key, ED8 2E 53 87 EF 0 E7 D. This is the key. And finally, -A. So we encrypted our plain text. So to display the encrypted cipher text, we can use a cat command, cat cipher text.inc. Here is it. It is already encrypted. So it is very difficult for us to read. But if you cut the plain text, plain the plain text, it is readable. So to decrypt this encrypted ciphertext, we can use this command, but with a few modifications. This ciphertext will be our input, and here we'll have a decryption command. So here we'll have an output file, out, decrypted .txt. So here is it. So to display what we have decrypted, cat decrypted cat decrypted. So we successfully decrypted the ciphertext. So this is all about encrypting and decrypting using DAS with a random key generated from our system. So try this and master it. So this is all about encrypting and decrypting using DAS. Have a good time.